Welcome to The Explainer. Today, you're not just a viewer, you're an engineer on a mission. A mission to understand how computers actually take away information. So get ready to think in zeros and ones, because we're diving straight into the world of binary subtraction.
Wallahi. You might hear that in our source material. It basically means truly or I swear. And we're using it because today you are a top engineer with a very important job to do. So welcome back, champions of the digital world.
So here's the setup. Picture yourself at a fast-paced tech startup in Lagos. Your critical task? Managing all the inventory. And to do that, you've got to master taking things away, but in the computer's native language. Let's get into it.
All right, let's talk about your engineering mission. This is our laser focus for today. By the end of this, you're going to be able to confidently subtract 3-digit binary numbers. Nailing this skill is absolutely the key to your success.
Okay, first step, a simple stock hack.
Let's start with a little warm-up. Let's say your startup has 1, 1, 1 in binary. That's 7 engine parts. You get an order and ship out 1, 0, 0. That's 4 parts. So how many are left in the warehouse? Okay, let's break this down. We work from right to left, just like you would in regular subtraction. So in that first column on the right, 1 minus 0 is 1. Easy enough. In the middle, 1 minus 0 is 1 again. And in the leftmost column, 1 minus 1 is, of course, 0. So the answer is 0, 1, 1. Omo, easy work. That's a great Nigerian expression of surprise, and in this case, a good surprise. That was simple, right? A clean calculation and boom, inventory updated. But as any good engineer knows, it's not always going to be that simple.
And this is the real heart of our mission today. The easy problem is subtracting 0 from 1. We just did that. But what happens when you flip it? How do you subtract 1 from 0 in a world that only has ones and zeros? Now that is the real challenge.
To solve this puzzle, we need a special tool. It's called the borrowing rule, and it is the absolute secret to mastering binary subtraction. So here's how it works. Whenever you get stuck on a 0 minus 1 problem, you just look to the column immediately to the left. You borrow the 1 from that column. But here's the magic. When that 1 moves over, it doesn't just stay a 1. It becomes 1, 0. Now this is the crucial point, the real aha moment. That 10 you just borrowed isn't the number 10. In binary, 10 is the number 2, right? In our normal base 10 system, each column is 10 times bigger. In binary, each column is only 2 times bigger. So when you borrow a 1 from the 2's column, it becomes 2 1s in the column you moved it to. That is the whole trick. Okay, theory is one thing, but engineers learn by doing. Let's master the borrow. So here it is, the real test. You've got 6 or 110 packets of ground nut in stock. An urgent order comes in for just 1, or 0.001. It's time to calculate the remaining stock using our new skill. All right, let's walk through this together. Starting on the right, we have 0 minus 1. We can't do it, so what do? We borrow. We look to the middle column, take that 1, which now becomes a 0. That borrowed 1 slides over to the right and becomes 10, which we know is really 2. So now, in that right column, we have 2 minus 1, which is 1. Perfect. Now the middle column. It's just 0 minus 0, which is 0. And finally, on the left, 1 minus 0 is 1. And there is our answer, 101. In our decimal system, that's the number 5. We started with 6 packets, we sent out 1, and we have 5 left. The system works. Mission accomplished. All right, you've seen the easy problems, and you've totally mastered the tough ones with the borrowing rule. Let's do a final evaluation. So, your objective was to subtract 3-digit binary numbers, and you've done it. You proved it. After what we just did, 2-digit problems are going to feel like a total breeze. You've definitely got the skills to manage that inventory. So you've mastered subtraction, a fundamental building block for how a computer thinks. But it really makes you wonder, doesn't it? If this is how a computer subtracts, how on earth does it use this one simple action to do something way more complicated, like division? Well, that's a question for another time. Thanks for joining us.